So finally, let's consider cardiac output. Cardiac output is defined as the amount of blood the heart is able to beat in 1 minute. And normal blood flow at rest is about 5 liters per minute, which also just happens to be the normal blood volume. So we basically circulate the blood volume about once every minute at rest. During exercise, depending on how in shape you are, getting up to 10 liters per minute is very easy. If you're doing a little bit harder exercise, 15. Really, truly in shape athletes can get 20 to 25 liters per minute of blood flow, which is a lot. So let's do some definitions. I'd already said end diastolic volume, EDV, is the volume of the blood in the heart at the end of diastole. Then we have this concept called stroke volume. That is the amount of blood the heart is able to actually eject into the arteries. What volume? And that's per beat. So how much blood is in 1 beat? We also think of it in terms of ejection fraction. What percentage of the blood is actually being pushed into the arteries? So we had end diastolic volume, and what percentage of that is actually pushed into the arteries? And so normal is about 50 to 60%, depending on who you ask. And we have an equation. Stroke volume is equal to the end diastolic volume times the ejection fraction. An example would be if I had, and I give you the equation again, if we had an ejection fraction of 55%, that's 0.55, and if my end diastolic volume was 120, we multiply it through and we get 66 milliliters. And this is the same problem I did in class, but I want you to think of this person as person 1, because we're going to do some comparisons in a minute. Or we could do it the other way around. We could do ejection fraction is the stroke volume divided by the EDV. And so if I've changed the numbers, I didn't want to do the same numbers. So if my end diastolic volume is 140 and the stroke volume is 80, what is the ejection fraction? And so 80 divided by 140, remember this is not pressure, this is not blood pressure, this is volumes, this is milliliters, gives me an ejection fraction of 0.57 or 57%. And we're going to call this person person 2 because they have a different volume. So then cardiac output is equal to the stroke volume times the heart rate. In my example from class and continued from above, we have the stroke volume of 66. We gave them a heart rate of 70. We multiply it through and we got 4,620 milliliters per minute, which is pretty close to 5 liters. But now we're going to do some comparisons. We're going to be able to compare cardiac output, kind of a way to determine who's in the best shape. So from above, or from the previous lecture, if person 1, which we saw already has an EDV of 120, a cardiac output of 4620, so 4,600. If their ejection fraction stays the same at this 55%, but their end diastolic volume goes up to 150, they went for a walk, right? So they went out and exercised. Their heart rate will increase to 110. So this is what exercise does. And this is very mild exercise. They went out for a walk. They decided to get out of the house and go for that walk, which might be what I do after this lecture. So what is their new cardiac output? Well, we know that stroke volume times HR is cardiac output. So we start with stroke volume, which we now know the new EDV, same ejection fraction, 82.5. I'm going to stress again, don't round. Don't round until you're done. Just keep that number in the calculator. We said that they have a heart rate of 110. Now they're getting 9,075 milliliters per minute. Not quite doubling their cardiac output for only a little bit of extra effort. This is pretty good. They've got that little bit of extra blood flow that they need to do their exercise. But remember person 2? Person 2 had a slightly higher EDV, and they had a slightly higher stroke volume. We didn't do the heart rate before, so I'm going to do it here. I'm going to say their heart rate's 65 beats per minute. So we have the 80 times the 65, they get 5,200 milliliters per minute, which is slightly more than 5,000, but it's really close, and it's slightly more than their friend, person 1. Now, if person 2 goes on the same walk with person 1, maybe they are able to go out together and walk together, but their EDV goes up to 160. That's only a little bit, right? Compared to the other person, they had 150. Their heart rate only goes up to 105 instead of 110. So they have a little bit lower heart rate. So their new stroke volume is the 160 times the 57, because that stays the same. So they get 91.2 milliliters. Again, don't round. That's the big thing people try and do. Don't round. Cardiac output is equal to that times they get 9576 milliliters per minute. Not even close to double, but still pretty good. So if we compare the two, we see that person 1 at exercise got 9,075 versus 9,576. The key here is efficiency. We got more blood for less effort. The heart rate of 105 means that they didn't have to put as much effort into getting that same heart rate because their efficiency, their ejection fraction was slightly higher. So person 2 is in better cardiovascular health because they're able to move more blood with less effort. And that's the key when we're looking at cardiac output. So for the exam, the key idea on the exam is you must be able to solve the equations. I will give you the equations, but you must be able to use them correctly, and you have to be able to analyze the results. Don't tell me that somebody has better cardiac health when they have to work harder to get the same amount of blood or less. So you have to be able to use the equations, but there will be a problem on the exam.